So the first series, we can use the p-test. Since the p is greater than 1, we know that that series will converge. In the second one, the p-test again, the p is equal to 1, so the series will diverge. And in the third series, doing the alternating series test, finding out the u sub n is greater than 0 for n between 1 and infinity checks out. And the square root of n plus 1 is bigger than the square root of n, so 1 over the square root of n is going to be bigger than 1 over the square root of n plus 1. So the second condition checks. U sub n is greater than u sub n plus 1. And the limit as n approaches infinity of the u sub n term, which is 1 over the square root of n, is equal to 0, so that also checks. And so then the series negative 1 to the n over the square root of n converges, so both 1 and 3 are true. So by conducting the ratio test, we can figure out what values the series will converge. So looking at the limit as n approaches infinity of x minus 1 to the n plus 1 over n plus 1, all over the a sub n term, which is x minus 1 to the n over n. Multiplying by the reciprocal, we have the limit as n approaches infinity of x minus 1 to the n plus 1 over n plus 1 times n over x minus 1 to the n. And then reducing to get limit as n approaches infinity of x minus 1 times n over n plus 1. So that leaves us with x minus 1. Taking the absolute value of x minus 1 less than 1. So x minus 1 is between negative 1 and 1. And so x is between 0 and 2. And now we need to check the endpoints to find out if any of the endpoints are converging. So when x is equal to 0, we have the series n equals 1 to infinity of negative 1 to the n over n. By doing the alternating series test, you can see that 1 over n is greater than 0 for all values of n between 1 and infinity. N plus 1 is greater than n, so 1 over n is going to be greater than 1 over n plus 1, so the second condition checks out. And the third condition of the limit as n approaches infinity of the u sub n term, which is equal to 1 over infinity, is equal to 0, also checks. So since the alternating series test proves convergence, x equals 0 is going to be included. And now checking for x is equal to 2, that series will be 1 to the n over n. So the series is from n is equal to 1 to infinity of the function 1 over n. And that diverges by the p-test since the p-value is equal to 1. So then the value of x is equal to 2 is not going to be included, so then letter choice D. To test convergence on the first one, we'll do the alternating series test. So first checking that 1 over 2 plus n is greater than 0 for n between 1 and infinity. And then letting f of x equal to 1 over 2x plus 1, taking the derivative, we get negative 1 times 2x plus 1 to the negative 2. And that will be less than 0 for the values of x between 1 and infinity, so that checks. And then looking at the limit as n approaches infinity of the u sub n term, which is 1 over infinity, is equal to 0. That also checks out. Therefore, the series for number 1 converges. For number 2, using the ratio test, the limit as n approaches infinity of the a sub n plus 1 term divided by the a sub n term. And then reducing this to get the limit as n approaches infinity of 3 halves times n over n plus 1, which then becomes 3 halves. And since 3 halves is bigger than 1, the series will diverge. And then for number 3, using the integral test, the limit as a approaches infinity of the integral from 1 to a of 1 over x ln of x dx. Putting u equal ln of x, du dx is equal to 1 over x, and then replacing in the values of u, there's a limit as a approaches infinity then of the integral from ln of 2 to ln of a over 1 over x times u and then x du. So that's the limit as a approaches infinity of the integral of ln of 2 to the ln of a of 1 over u du. That antiderives to get to the limit as a approaches infinity of the natural log of the absolute value of u from ln of 2 to ln of a, which then is infinity, so that series diverges. So only letter A is the choice.